Okay, we're back. This is for AP Physics C, E&M. Check-in number 8 has to do with DC circuits. So we're going to give this a try, see what we can do with these. The first circuit is a pretty big one, so you might want to take a little bit, if you haven't seen the circuit yet, to go ahead and pause the video and draw it out for yourself and see if you can make sense of it. This particular circuit has an A and B that was open up. So it's an open circuit, but it has a slew of resistors here. 2 ohms, 3 ohms, 14. Then in the next branch, 4, 5, 12, 6, 10, or 8 and 10. And it asks for what is the total resistance between points A and B. Okay, so the way in which you handle these type of situations would be to start as far away out from the power supply as possible and then move. And effectively, I guess I'm saying there is going to be a power supply over here at A and B, but as far away from the open part of the circuit as possible and move over. So go from right to left. These 3 resistors right here are in series, so they will add together. So if you do that, I think you're going to have a 6, 8, and a 14 give you 24 ohms of resistance. And then that will be in parallel with the 5, so you'll take 1 over 24 plus 1 over 5, take the reciprocal. When you do that, I think you get 4.14 ohms of resistance. Then that will be in series with the 4 and the 12. So 4 and 12 is 16, and 20, you get 20.6 or 20.14, and then that will be in parallel with a 3, so you'll take 1 over 3 plus 1 over that, take the reciprocal. And when you do that, I think that gives you 2.61. Remember that when you take the reciprocal, you should get a number less than any of the other resistors. So when we took 1 over 5 and 1 over 24, we got less than that. And 1 over 3 and 1 over 20 gave you less than 3. When you add those two together, or those two with that, so 2 plus 2.61 plus 14, you get a total of 18.61 ohms. I believe that's what you get. So go ahead and give that a shot and see if that makes sense to you, that you in fact get that as your total resistance. So that's just the first step. I'll save this sheet of paper here because we'll probably have to come back to it. But the next question is, what would happen if you took a 100 volt power supply and connected it from points A to B? Now you've got 100 volts. So you have a 100 volt power supply and connect it across there, and then you do the problems and determine what is the current in this 12 ohm resistor right in that spot. So you want to find the current in the 12 ohm resistor. So I think if we push all of this over, you can then figure out what the total resistance at that point was. And I think we always started those problems last year when we did just the simple circuitry. If you want to find out what the total current is, you take the total voltage and divide by the total resistance. We said that you have 100 volts, and now our total resistance was 18.61 ohms. That gives you a total of 5.37 amps of current. That's the total amount of current that flows through that circuit. And now the second step would be, or the next step would be, to find out what was happening when you looked at this part of the circuit. Remember that when you broke this down and got 24, and then you took the reciprocal, and that ended up 4, and then you took the reciprocal, that gave you 2.61 ohms of resistance for all of that. I think we can find out what the voltage for all that part of the circuit would be, the voltage in the across that 2.61 part of that resistor, or that set of resistors. You take the current, and that would be the total current, 5.37 amps, and multiply by that 2.61 ohms of resistance. And if you do that, that gives you 14 0.03 volts. See if we can figure out what that means. We have a 2 ohm resistor, a 3 ohm resistor, which is now, the 3 ohm resistor has now been replaced. All of that is replaced by 2.61 ohms, and then 14. The three parts, 2, 14, and 2.61, all have to split that 100 volts. And so what we're saying is 14 volts of that is actually present at the 2.6 ohm, that part of the circuit. So the current in the 3 ohm resistor should equal the voltage of the 3 ohm, which is the same as what we just calculated over the resistance. So let's try to figure out, if we did that, we took 14.03 volts and divide by 3 ohms of resistance, that would give us 4.67 amps of current. And now let's think about what that 4.67 means. 4.67, current comes in, and this is the total current, and it's got two choices, either go this way or that way. Well, we just found 4.67 was the amount that went through that resistor. If you think about it, then that leaves whatever, if you subtract these two numbers, then you will in fact get what the current is left in the rest of the circuit. So the current in the 20.14 ohm resistor, whatever's left for the circuit, would just be 5.37 amps minus the 4.67 amps. And if you do that, you get 0.695 amps of current. 0.695. That would be the amount of current that goes to this part of the circuit, which in fact would be whatever was the 12 ohm resistor. So that's the answer for the 12 ohm resistor, would be the 0.695. The last step would be, what is the power dissipated in the 3 ohm resistor? Power is V squared over R, or IV, or in this case, I squared times R. I already know what the current is, so I'm going to use that. 4.67 amps, square it, and then multiply by the 3 ohms. And that'll give me how much power is dissipated in that part of the circuit. If I do that, I get 65.4 watts. Okay? That's how I would get those. So if you pause at each step, see if those numbers make sense, and we'll go from there. Okay? So that's one harder circuit. The next question here is more of a graphical question. Determine the voltage given the following graph. Well, it is a power versus current graph. So we're graphing power versus current, and we're asked for, how do you find the voltage? Well, the voltage should just be the slope of that graph. Power versus current. So in here, assume that this was a graph and it had a grid on it, and these dotted lines represent the grid. I'm basically going to be looking for the change in the power over the change in the current, which would be the slope, the rise over the run of that circuit. So if I just do a little bit of work, this would be 4 at the top, and I think I'm going to estimate on the bottom this data. It's not a data point, but somewhere that is marked on the grid. Let's say it's 0.3. And I do the same thing with the x variables. Looks like the first one is 500 and the other is 100. So we take the rise over the run. Let's take a look at the units. The units here are milliwatts, and then of power, and milliamps of current. If you do that, you're going to end up getting that the voltage is 0.0093 volts, which is the same as like 9.3 millivolts, which is what a milliwatt divided by a milliamp. That problem came from probably an AP book or something. So they got you looking at a situation where you can understand how to analyze a graph. So this one would be a power versus current graph. Okay. We'll go on to more of a graphing. The last problem is more of doing the same kind of thing. Here it gives you a power versus voltage graph, and it's a curve. And they ask you the question, what could you do to linearize that graph? I.e., what variables would give you a straight line? So pause, think about that, and come back. If you want to take that curve and make it a straight line, that would be if you graph power and voltage squared. You square all the values on the x-axis, and then that's going to give you a straight line. That's what is meant by linearizing the graph. So you got to get used to looking at that. I think I'm going to give you a worksheet that asks you to do more of that, but that's how you handle that situation. And if you see that on the AP test, they're probably going to ask you to be looking at that. The last one would say, what is the slope of the straight line? If you get the straight line graph, what would that slope represent? Well, the slope, again, is the rise over the run, so that would be the change in the power over the change in voltage squared. Well, don't you have an equation that says P equals V squared over R? I think the last step would be to say, well, if that's the case, then if you took P over voltage squared, that's going to give you 1 over R. So the slope of that is the reciprocal of the resistance. Not the resistance, but the reciprocal, 1 over R. Okay, and that's what happens sometimes on the AP exam. For them to linearize it, they would just want you to look at what the slope would give you. I hope that makes sense. That's all I got for you on this one. Hope you are staying safe. Talk to you next time. Thanks.